Okay, so today we have more related rates, and this question says that two cars start moving from the same point, and one travels south at 30 kilometers an hour, and the other travels west at 72 kilometers an hour. So, if we think about two cars traveling in different directions, we know that south is this way, and we know that west is this way. So they tell me that the one traveling south does so at 30 kilometers an hour. So I can say, well, if I have my car traveling south, then I can denote this as car traveling south is changing with respect to time at 30 kilometers every hour. And the same thing for the car traveling west. I can say, well, if the car traveling west is doing so, then it's changing at 72 kilometers an hour. Okay, now we have a car traveling west, which is this way, and a car traveling south, so hence we've created a right angle triangle if we connect this distance. Okay, and they want to know at what rate is the distance between the cars increasing 2 hours later. So the distance between the cars is going to be this distance, because if they start at this point, then as time goes on it's increasing and increasing. And let's suppose that at this time it's 2 hours later, so let's just say we want to know this distance. Let's call it r. Okay, we want to know at what rate is r changing 2 hours later. So mathematically we want dr with respect to time, uh, two hours later. Okay, and putting this in a box because this is important. Okay, so before we start, let's make this valid. Let's assign our variables so that we're not just talking about some random stuff. So we can say, well, let W be the car traveling west. Oops, this is supposed to be 1L. And S be the car traveling south. And we can say, hence, creating R the distance between the two cars. Okay, and yeah, I think that's all we need to state. So we basically said let this be the car traveling west and let this be the car traveling south, hence creating R, which is the distance between the two cars. So now we can say, well, by Pythagoras, okay, we can say, well, r squared is going to be equal to w squared plus s squared. Okay, so here's my hypotenuse and then my two sides. And how do I know it's the hypotenuse? Well, it's across the right angle. Okay, so I don't really want to differentiate r squared, so let's take the root of both sides, and if I do that and simplify, it's going to be r is equal to the square root of w squared plus s squared. Okay, now I want to know how fast r is changing, or hence I want to know dr by dt. So let's take the derivative with respect to time, which is going to give me dr by dt. But before I do that, notice how I can just write this as w squared plus s squared to the power half, and that's going to make it easier for me to differentiate. So taking the derivative of both sides, this is going to be dr by dt, and then using chain rule, this is going to be half w squared plus s squared to the minus half multiplied by 2w dw dt plus 2s ds by dt. Okay, and how did I do that? Well, doing chain rule, we bring this to the front, minus 1 from the exponent. I copy down whatever's in the brackets first, and then we multiply by the derivative of inside the bracket. Okay, so if we just ignore everything and take the derivative of just the inside, we get this part. Okay, so now we can simplify this. How would I simplify this? Well, with practice, we can see that this is just going to be 2w dw by dt plus 2s ds by dt all over 2 into the root of w squared plus s squared. And how did I do that? Well, I said this is going to be multiplied, so I took it over and put it on the top, and then I said this is a negative exponent, so we can just pull it to the bottom and convert it back to a root. Okay, so now all we have to do is just plug in what we have. So, well, actually what we don't have yet is the exact value of w and s. Well, we know that the cars traveling are denoted by those variables, but we don't actually know what they are, because we know how fast they're changing, but we don't know what they are. Now they tell me that they want it 2 hours later. Okay, and I know that the car traveling west is going 72 every hour, and the car traveling south is going 30 every hour. So I can say, how can I say this? I can say 2 hours later implies that w is going to be equal to, so if we take 72 and multiply by 2, we get 144 kilometers an hour. Oh well, not every hour, just kilometers. That's how far they've traveled in 2 hours. And this also implies that the guy going south traveled 60 kilometers. Okay, now this is going to be equal to 2 into 144, and we know that w is changing at 72 plus 2 into 60, and that's changing at 30 all over 2 into w is 144 squared plus 60 squared. And if you put this in a calculator, well, you could simplify this, but yeah, nobody got time for this. Just if you put this in a calculator, you should get 78 kilometers every hour. And then you can conclude, you can say, well, hence the distance r between car w and car s is changing at 78 kilometers every hour after 2 hours.